In this portion, I'm going to discuss how to create contrast codes. So this hopefully will ring a bell in your memories from a NOVA class because it is very similar. So we have this, again, this predictor variable or IV that is categorical and has 3 or more levels. And so we need to, again, we're making this hypothesis a priori that certain groups will differ from other groups. And so I think the simplest case to start with is just 3 groups. So in SPSS, we will be creating these codes, and I will show you how to do that in an upcoming screencast. But for now, just conceptually, let's think about the different things that we could test with these 3 groups. So for contrast code number 1, the hypothesis there is that we are contrasting the Family Studies Department and we're comparing that or contrasting that against the average of the other 2 departments combined. So we are thinking maybe, I'm just going to hypothetically create a situation. Let's say that the Family Studies faculty are a little bit discouraged about their salary in comparison to the other departments. And so you as the researcher are going to see if those concerns are justified. Are the Family Studies faculty members being paid less overall than the other 2 departments? So that is depicted as contrast code number 1. So we are going to assign a certain sign to the Family Studies Department, and we're going to assign it a negative sign. And that's arbitrary. We could have assigned the other departments a negative sign, and then the Family Studies a positive sign. But what we want to do is create the contrast such that the departments that are being compared against the other department are all going to have the same sign. And then the other departments that we're comparing against, they'll have the opposite sign. So that's the idea with contrast coding, and hopefully that's exactly the same as what you remember from ANOVA. Furthermore, the weights of the contrast have to add up to 0. So in this case, when we have 3 groups in the comparison, we can do a negative 2/3 and a positive 1/3 and a positive 1/3. Okay, so again, we could have done a positive 2/3 and a negative 1/3 and a negative 1/3, and that is the exact same. So it's the same contrast, but the B weights later will be interpreted differently. Okay, so we'll come to that in a few minutes. Okay, so we have the first contrast code, and then we have a second one, which is our choice as the researcher. We do not have to have another comparison, but let's say that we have faculty members in biology saying that we are being paid unfairly compared to business. And so you are going to, as the researcher, test that one also. So we are leaving Family Studies out of this contrast, so we are going to assign it as 0. And then we're going to do a half and half because there are 2 groups being compared. So we're going to do a negative 1/2 and a positive 1/2. Now please make a note that in SPSS we can't do fractions, so we're going to change those fractions to decimals. So negative 2/3 will become negative 0.66 approximately. There's going to be some rounding error. That's okay. It's going to be close enough. And then for 1/3 we're going to make that a 0.33. And then for the halves, we're going to do negative 0.5 contrasted with a positive 0.5. So don't forget that in SPSS we cannot use fractions. We'll change them to decimals. These 2 contrast codes are orthogonal to one another. That means they're going to be uncorrelated, and that's very important if we're doing 2 contrast codes for one analysis like this. Again, we do not have to. If we just had the first hypothesis, then we will go with just contrast 1 and not worry about making these orthogonal and adding another contrast. But I just want to show you an example of 2 codes and how to make them orthogonal, just in case you need a refresher. This will be just for reference. I set these up beforehand using the instructions in Field starting on page 445, and so I find that to be a good reference. And just so you know, I will never ask you to do a complicated orthogonal analysis like this. I'm not going to ask you for 5 groups to make 4 orthogonal contrast codes, and here's the hypotheses I want you to test. That is beyond the scope of this class, and it's something that I think most of us would have to go and use a reference book for doing that, unless you're very familiar with creating these codes. And again, there are very few cases where you would want to test all possible orthogonal contrasts. Recall that the max orthogonal contrast you can test is the number of groups minus 1. So we have 3 groups in this case. The max orthogonal contrast we could do is 2. Okay, so that's important to know. That fact, that conceptual fact, but beyond that, here's what I want you to pay attention to. What is the reason for using contrast coding versus dummy coding, and what are the pros and cons to each? Okay, so that's something you'd need to know. You'd need to know how many codes you need to make for dummy coding to fully represent a predictor variable, and that is the number of groups minus 1. Similarly, for contrast coding, what's the max number of contrast codes that can be made that could be orthogonal? And it's the same answer, and that's the number of groups minus 1. So those conceptual pieces are important. But beyond that, the information I'm giving you is kind of supplementary and for reference only. So, and also I would expect you to be able to do a contrast code that's very simple. For example, contrasting 2 groups against one another, that would just be a -1, +1, or -1 half, +1 half. Those are fairly easy. Maybe doing one group against 2 other groups, so that would be this -2/3, +1/3, +1/3. But as far as like more than 3 groups, and these just more complicated analyses, I would not ask you to do that without access to a reference. It's just too much. But I'm going to give you now some supplementary information that you can use for reference. So there are some notes at the bottom of this slide that talk about the ways to weight these contrasts depending on your research question. So that's the part that says examples of contrast coding schemes that are most often used. So when we're comparing 2 groups against one another, we could use a -0.5 and a +0.5, or -1, +1. It does not matter. As long as they add to 0, you could use either one. I find that perhaps it's just easier to do -1 and +1, because it's just easier to type into SPSS, and maybe it makes more intuitive sense. Whatever makes sense to you, just go ahead and use those, but you need to indicate in your publication, when you do present your findings, that you coded it in this way, so that the reader knows how it was done, because that does affect the interpretation of the B weights. So that's important to think about, and again, if you need more information on that, just look in field, and also the article that I referenced earlier on about contrast coding and how to do it. The second very common way that we test differences between groups or among groups is in the 3 variable case, or I'm sorry, the 3 group case, like we did in this slide. So we have the 3 departments, and so we're going to pit one group against the average of the other 2 groups. So family studies, mean against the average of the other 2 departments. And we can just do a simple 2/3, 1/3, 1/3 scheme for that, and make again, the family studies, the one you're contrasting, the opposite sign of the other groups. We could also have 4 groups where we're testing the average of 2 groups against the average of the other 2 groups. So let's say we had 4 departments, and we were curious if these 2 departments are being paid more on average than these other 2 departments. That is like another kind of half and half, but you need to code this in a little bit different way. So again, all of the weights have to add up to 0. So we could do a 1/4, 1/4, and then -1/4, -1/4 scheme, as you can see. So in SPSS, you would literally put in +0.25, +0.25 for the first 2 groups, and then the second 2 groups would be -0.25 and -0.25. Or you can even be simpler and just do a positive 1, and then make the other two groups a -1 and a -1. So that's for a 2, 2, and 2 kind of scheme where you have this research question where you're wanting to compare 2 against the other 2. And finally, let's say you want to compare one group against the average of the other 3 groups. So again, we have 4 groups, but a different research question. So you could technically put in something like a +1 and then a -1/3, a -1/3, and a -1/3, and that would add up to 0 if you added those weights together. Or you could be even more simple and do +3 and then a -1, -1, -1. And again, those all add to 0, so they're completely legitimate. Now, if you had 2 or more contrast codes that you wanted to make orthogonal to one another, I will explain that in the next slide simply for reference. And in that case, you couldn't just simply do any of these that you wanted. You would have to do some manipulations with those, and there are resources for that you would look at and make sure those weights are all perfect and they add up correctly. But if you're simply doing one hypothesis with one contrast code, then you would just simply do any of these coding schemes below that I've laid out for you in the notes at the bottom of the slide. Okay, so to wrap up, again, we're doing contrast coding. This is when we have an a priori hypothesis, and we do contrast coding for the most part when we have a categorical variable with 3 or more categories, and particularly when we have a lot of different categories. If we had 5 or more in particular, we would want to save on DF, specifically numerator DF, and so we would reduce this and kind of reduce our hypothesis or our test, our research question, to one contrast code so that we have just one numerator DF for our hypothesis. This increases our power and saves on cutting into our SS regression too much. We do not want to do that. So that is the reason that we would do contrast coding.